Let's compare and contrast this to constant acceleration. So what does constant acceleration mean? It means you set it at a constant value. So I'm going to set this to 1 meter per second squared. Can you predict if I constantly accelerate, what will my position versus time graph look like? Will it be a straight line? Let me go ahead and collapse this so we just have position versus time. Is it going to be a linear relationship if we're speeding up, if we're constantly accelerating? What's it going to look like? Can you predict? Will it increase at a steady rate? Or will it start to curve? Wow, that's so exciting. It's going to curve, right? Because we are speeding up. In equal intervals of time, we are covering greater and greater distances. So this would be like if you're skiing down a hill or you're snowboarding, etc. You're accelerating. Gravity's pulling you down that hill. Why would we want to identify these different trends? Because if you have something complicated, like a sprinter, where the graph is linear and straight, like where it levels off here, then it's constant motion. So actually, this is kind of silly. This would be when the ankle hits the ground. So obviously, you're not moving. The slope drops to 0. But where it's curving is your point of acceleration. And where the slope is steepest, actually, is where your ankle is actually going the fastest. So we can actually pinpoint exactly where the acceleration is greatest. So why don't we summarize this? Let's make it easy first. So again, what would the position versus time graph look like? In this case, it's not a straight line. It's not linear. We're going to have a what? We're going to have a exponential relationship here, right? Because we're speeding up. We are accelerating. How about for the velocity versus time graph? If you're constantly speeding up, what would that look like? Can you predict? You're at a stoplight. The light turns green. You step on the gas pedal. What's going to happen to your speed? It should increase at a what? If you're constantly accelerating. At a random rate or at a steady rate? If you're constantly accelerating with your foot on the pedal, the same amount. It'll go up how? Exactly. At a constant rate there. So if you're trying to maximize your fuel efficiency, this would be a super useful graph. So I'm going to get rid of this. Let me rewind this. Get rid of this acceleration graph here. And then pull up the velocity graph. So here, notice, I'm going to go ahead and play this back in slow-mo here. The velocity just increases at a steady rate. It's like you're stepping on the gas pedal until like he hits the wall there. That's why there's that spike there. So see how it's a straight line up and to the right? And then finally, the acceleration graph is nice, constant, steady line because we're keeping our foot on the gas pedal at a steady rate there. This is my acceleration graph right here. Nice, steady line. We're accelerating at a nice, steady rate here. Got it?